Vectors 9.2 Systems of Linear Equations in R2. So here is the next question where we'll try to understand what values of k can make a system provide us with one solution, no solution, or infinite number of solutions. The question here is, consider the system of equations x plus ky equals to 6 and kx plus 9y equals to 18. Determine the values of k for which the system of equation has no solution, one solution, or infinite number of solutions, right? So let's work with these two equations, try elimination or substitution method, and try to figure out the values of k which can give us all these conditions, right? So the equations are x plus ky equals to 6 and kx plus 9y equals to 18, right? These values are carefully chosen so that we don't land up with fractions and we have very simple equations to solve. So let's number our equations so that it becomes easier for us to work with them. So let's say this is our equation number 1 and that is equation number 2. Now to eliminate x, we should multiply 1 by k, right? So we get equation number 3 by multiplying 1 by k. So we get kx plus k square y equals to 6k. So this is what we do when we multiply k times equation 1 equals to equation 3. Now to eliminate x, we can take away 2 from 3. So we do equation 3 minus equation 2. So if you do that, kx minus kx is 0 and you're left with k square y minus 9y equals to 6k minus 18. And now we can factor out y and simplify this. We get y k square minus 9 equals to, we can factor 6 here, k minus 3. On the left side, you notice the difference of squares. So it could be written as k plus 3 times k minus 3 equals to 6 times k minus 3. So that is what we get as our equation to work with. So with this, let me call this equation as equation number 4. Now let's analyze this equation now. So if I write equation number 4 here, let me rewrite this as y equals to k plus 3 times k minus 3 equals to 6 times k minus 3, right? So this is the equation which we'll try to solve now. So in this case, there could be different scenarios. If I put k equals to minus 3, then what happens? If I put k equals to minus 3, I get this side is 0 and this side will be something but not 0. Do you see that? So let me do that option first, and this is, I'll put k equals to minus 3. So if I rate k equals to minus 3, so that is case 1. So in that case, what do I get? So if I put k equals to minus 3, and that is my equation number 4, okay? So let me rewrite this as equation 4. So k equals to minus 3. In that case, the left side is 0 because anything minus 3 plus 3 is 0, anything multiplied by 0 is 0, so we get 0 times y equals to minus 3. If you put here, you get 6 times minus 3 minus is minus 6, which is minus 36, right? So 0y equals to minus 36, that is never true because this is always 0, right? 0 y equals to minus 36, that means 0 equals to 36, correct? That means 0 equals to 36. You know, 36 is a number which is not 0, and so this condition says not true. So that means if k equals to minus 3, we'll end up into a situation when there is no point of intersection and there is no solution. Do you understand? That is what it means. No solution at all. So let's see if it really is like that. So what we will do is we'll plug in minus 3 in both the equations for k and see what do we get. If I write k equals to minus 3 in equation number 1, I get x minus 3y equals to 6, and for the next equation I get minus 3x plus 9y equals to 18, right? Now this equation can be simplified, and dividing by minus 3 I get x minus 3y equals to minus 6. Now in this equation you can see that their directions are same, x minus 3y, x minus 3y, right? But their intercepts are different. Intercepts will be 6 divided by 3, right? Minus 3 rather. So their intercepts are minus 2 and plus 2. So they have different intercepts and same direction, and therefore these are parallel lines and they have no solution. Do you see that part? Correct? So here we get no solution, right? So you can actually draw these lines. So we'll make a small sketch of these lines, right? You can always sketch them. And in the first case, well, I'll go out of the page if I do it here. So what I will do is I will push my page a bit up. Okay, that's better. So here we are. So what we have here is, this is my equation number, let me say 1a, okay, and this is my equation which is 2a, right? In this, where we have put k equals to minus 3. Now if I plot this, what is my x-intercept? X-intercept is 6 and y-intercept is minus 2. So I have a line which is minus 2 and 6. So I have a line like this. So that is first line. Correct? And for the next equation, x-intercept is minus 6. Right? And the y-intercept is plus 6. So in that case, I have a line kind of, if I divide, you get plus 2, right? So we have the other line which is kind of like this. So these are two parallel lines and they will never intersect. So that is how the case is when k equals to minus 3. Now let me reconsider the same equation but different value of k's. So case 2, let's say case 2 is when k equals to plus 3. In that case, what happens? If I put k as plus 3, then my equation will be y times 0. So I get 0 times y, right? 0 times y equals to 3 will give me 0 here, right? So that means that implies 0 equals to 0, right? 0 equals to 0 is always true. So that means we are landing up with coincident lines. Is it okay? Let's check, is it really coincident or not? So how we can check? We'll put k equals to plus 3 in the original equation. That means these equations given to us. So we get x plus 3y equals to 6 for the first one, and the second one we get 3x plus 9y equals to 18. In fact, if I divide this by 3, I do get x plus 3y equals to 6. So they are exactly same lines. So they are coincident lines. So they will intersect at infinite points because they're exactly same. So that is for condition C. So this belongs to infinite solution. So what we have found here is, if k is minus 3, we get parallel lines with no solution, right? So this was no solution when k is minus 3. If k is plus 3, then we get infinite solutions. They're exactly same lines. And so we're left with case number 3. And case 3 for us is that k is not equal to plus and minus 3. In that case, these lines have different directions and they will intersect at one point. So then we have a consistent system with one solution. Do you see that? So that is how we can actually solve these equations and understand for what values of k are we going to have different conditions. That means lines could be parallel, in that case no solution. Lines could be exactly same. The system will be consistent with infinite number of solutions, and lines are not parallel. In that case, case number 3, we get one solution. They will intersect at one point. I hope the point is clear. And now we'll take some more examples to elaborate on the same. Thank you.